In question number 42, we need to find the current measured by the ammeter in the circuit shown in this figure. So, one way to solve this problem could be to set up Kirchhoff voltage law in this, and this loop, 4 loops. There will be 4 variables and solve for this, and it gets tricky here. The one thing, if you have seen my Wheatstone bridge tutorial, you will know that we can exploit the symmetry in this figure. Usually in the Wheatstone bridge, if you know the way why the resistance, when the Wheatstone bridge becomes balanced and there is no flow of the current, this is an extension of the Wheatstone bridge, and instead of one this resistor, we have 2 such resistors. The circuit is highly symmetrical. If you, to analyze the circuit, mentally remove these 2 resistors, and we know that these are symmetrical, and think of the current flowing from here, and it goes to this branch and returns to this. Another path is current goes from here, goes to this branch and returns through this. Now, because all these resistors are equal 10, 10, 10, 10, 10, 10, because of this flow of the current, there will be a voltage divider by these 10, 10, 10 ohm resistors. And in the same way, there will be divider voltage division between this 10, 10, 10 ohm because of this flow of this current. As a result, focus on this point here and a point here. The voltage at this point is going to be exactly the same as the voltage at this point. It means there is going to be no flow of this current on this 10 ohm resistor. In the same way, because the circuit is completely symmetrical, the voltage at this point is going to be exactly same as the voltage at this point. It means there is no flow of current on these 2 resistors. In other words, from this whole circuit, we can remove these 2 resistors with no change in the current flowing from this circuit. You should also notice that even if the ratios of these resistors were same, the result would still hold. For example, if this were 10, 20, 30, 10, 20, 30, the result could still hold. Even if this could have the same ratio, for example 10, 10, 10 and 20, 20, 20, we could still remove these 2 resistors and find the equivalent resistance and calculate the current. So with these things in mind, you can go ahead and show the circuit like something like this. And now we can just do this series of these 3 10 ohm resistors is going to be 10 plus 10 plus 10 is 30, and 10 plus 10 plus 30. 30 ohm and 30 ohm are in parallel, equivalent resistance 15 ohm. Current, to find the current, we divide this voltage V. I is equal to V by R. V is 6 volt, R is 15, so it's divided by 3. 3 into 2, 6, 3 into 5, 15, 2 by 5 or 0.4.